As AI adoption accelerates, enterprises are struggling to manage the sprawl. From GPUs and Kubernetes clusters to legacy infrastructure is still powering mission critical apps. And that sprawl creates cost, complexity, and of course, blind spots. And that's exactly the topic for today's discussion. Today, I'm joined by Matthew Shaxted, co founder and CEO of Parallelworks, to discuss their new AI control plane, a platform designed to unify AI infrastructure orchestration across modern and legacy environments with native Kubernetes support and GPU as a service integrations. We will explore why this kind of orchestration is becoming essential and how Parallelworks is helping enterprise teams bring efficiency and control to AI at a scale. Matthew, it's great to have you on the show today.
Yep, happy to be here.
As we were talking before the recording started, the company is over 10 years old, but you and I, this is the first time you and I are talking together. So for me, we have covered Parallelworks, TFiR a lot, but this is the first time I'm talking to you. So I'm also kind of curious. Of course, a lot of time has passed since you created the company, but I want to know just a bit about the history and story when you co-founded the company and where we are now today, how you have seen the whole journey of this whole industry and ecosystem, where you also see the company has also evolved, and what problems are you trying to solve now?
Yeah, so like I said, 10-year-old company. My partner, Mike Wild, and I, we spun out of Argonne National Lab. He was a researcher there for many years and was building technology to help practitioners, engineers, scientists run large-scale simulation campaigns primarily at the time on big iron supercomputing systems that you find at the national labs and some organizations as well. So we kind of came from that world, the world of batch schedulers, supercomputing systems, buildings that take up an entire building, for example. They have specialized networking, latest generations of CPUs. They have, massive storage systems generally. And these type of HPC systems, high performance computing systems, are designed to all act together as one to solve a particular challenging, primarily physics-based problem, but different types of things. So we came from that world. We really started as a user interface on top of these large-scale supercomputing systems with the goal of democratizing large-scale computing for industry. That was kind of the initial thrust of the business. We were focused on parallel computing and how that overlaps with workflow orchestration, hence the name Parallelworks. And that world that we came from is highly specialized, niche, high performance computing. And over these 10 years, we've seen it evolve a lot and really kind of pave the way into the same type of AI infrastructure that we see today. Different types of hardware and whatnot, but a lot of the same characteristics are similar. So that's a little bit about where we came from as a company.
How much things have changed when it comes to high performance computing or AI from those days to today? Because not only, of course, there is a whole set where you need super high-end machines for model training, but you can run any model even on a laptop or even phones these days. So how have the things evolved, and what are the new challenges you are seeing when it comes to managing AI infrastructure at a scale?
Yeah, and I've seen it kind of evolve, again, from our lens of the high performance computing side, where 6 years ago, we started seeing cloud infrastructure being able to be deployed inside of the hyperscale clouds, and you can get similar performance as a current generation, Cray InfiniBand machine, for example, or in some cases, like in Azure, they actually we're putting those things on the floor. So performance, for a long time, there was kind of this notion that, you can't get the same performance in the clouds. That whole trigger point started to happen about 6 years ago. You could start to deploy things in the clouds, tune them, get storage systems on there that would then perform to these on-prem systems. And our company started allowing these organizations to go hybrid at the time. They want to use a single piece of software to go between their on-prem infrastructure and these new cloud HPC systems that were coming out. within the last 2 years for us, we're seeing these same type of organizations wanting to bring in accelerator systems. And a lot of what I've been seeing, at least, is that organizations start with a managed service. They'll go into AWS, Azure, Google, Oracle. They'll run on their managed AI services that are all kind of set up and ready for you to run, SageMaker, the ML Studios, Vertex, et cetera. There's so many different ones. Then organizations are starting to, once you reach a certain maturity level, then, at certain scales and at certain maturity, maybe it's time for us to actually purchase our own accelerator system. And you're going to buy it. And that takes that kind of transition into the world of private AI. There's a lot of challenges that go along with that. There's expertise required. If your organization is not ready to operate a computer system of that scale, you can buy it from NVIDIA and put it on the floor. But they're generally large investments, and you want to get high utilization out of those things. So in terms of challenges, it's kind of this transition from using the managed AI services into private AI, which I think we're going to be seeing a lot of, in these upcoming years. We already are seeing some of that, but the challenges that present themselves is how do we actually operate that system, the big investment we made to get high utilization and get to productive output. People are using it for productive, applications within their organizations. So that's a little bit on some of the complexity. There's a lot of tools out there that help do this. And honestly, that I think contributes to the complexity. There's noise, and are we going to deploy Kubernetes? And, how do we actually start managing that? We have our cloud team, but it's a whole different thing a little bit. It's kind of issues around this that we're actively trying to address as a control plane software.
You have integrated Kubernetes into Parallelworks control plane. How does that, first of all, enhances orchestration for AI workloads in the real world environment? At the same time, you don't make things too complicated for teams and organizations who want to leverage it.
We worked with two stakeholders, basically, as a company and as our software product. It really solves challenges for two stakeholders within an organization. There's the infrastructure team and the IT organization that's responsible for managing the computing environments. Very rarely are the groups that we're working with running purely on a single type of system. They may be operating in a single cloud or multiple clouds. I'm seeing that much more as well with, GPU as a service providers and neo clouds. Groups that were once very comfortable running in an Azure for a decade now need to start perhaps looking elsewhere for different type of capabilities in the cloud. And then in an on-prem perspective, we're kind of seeing virtualized environments are still very much here. VMware is very much present. People are looking for alternatives to that to be able to complement their virtualized environments and perhaps move to different types of licensing models. That's something that we've been seeing. Many of the organizations we work with, again, are HPC in nature. They're running physics codes and bigger training jobs from more of like a predictive perspective for their physics codes. So they're working in batch schedulers still. And for us, they're very much still in play. So this mix of different infrastructure types and schedulers really brings a lot of complexity for the teams that are managing them. You need a cloud team that's expert in managing AWS, Azure, Google, Oracle, and now these new neo clouds that sometimes they're provisioning Kubernetes. So great. Are we going to hire specialized Kubernetes experts? Maybe they got to do that. Who's going to manage the existing batch scheduler infrastructure? So what we did is said, we are going to pick off very specific aspects of what makes a Kubernetes deployment complex, which from our view relates to bringing in multiple of them. So I have multiple Kubernetes systems, maybe in cloud, maybe on-prem, maybe sitting on people's, desk or in a lab somewhere. And we're doing kind of simple things about unified or centralized namespace group management, MIG management across all the different clusters you may be provisioning, and then chargeback and usage reporting. Very specific things. But we do that in the context of unifying it to the other infrastructure types we also run on: virtualized environments, batch infrastructure, hyperscale clouds. Because rarely and this it does happen rarely though, an organization, at least we're talking to, is saying we're ready to move everything to Kubernetes 100%, and we're starting totally green. A lot of times it's about a migration, and this pathway of moving from managed AI systems or managed clouds that maybe have our Kubernetes sitting out in a public cloud somewhere, eventually reaching a point that you want to bring that on-prem. What's that migration process look like? These are the types of problems we're actively solving, and rolling Kubernetes in lets these organizations just pick that up and slide it out in from an infrastructure management perspective, much like the other ones are already operating. And I'll just very quickly summarize on the other side of the spectrum, the end users themselves. We make an interface that lets them have a single uniform interface to access these clusters that are being stood up, regardless of the variety. So they have a single API, they have a single interface, web interface that they can log into and access the resources and consume them in a very familiar pattern. And I don't have to go into the Google console, learn that entire thing, and provision a GKE system over there, versus pick your cloud, CoreWeave and get a Kubernetes cluster over there. They're all kind of very different. We're trying to just unify the entire end user experience so that when people come in, they want to use the resources, they can get productive in their work, day one.
ParallelWorks also supports GPU as a service Kubernetes and legacy systems. Can you explain how your platform brings all these together into a unified management experience? Because you are kind of lowering the barrier of entry, making things easier for developers and teams without making too much compromise on the capabilities that they expect.
You hit on this earlier, and you were exactly right in saying that AI systems are more accessible than ever. I can buy a Spark box, or I can put, I got a GPU on my desktop under my floor here, and I can run inference or training models of various sizes or even LLMs and pull them down and do that. It's very accessible. But as you start kind of expanding the use, and then you want to operationalize the use with a lot of a larger organization, and we're talking starting with 5 people, 10 developers, people wanting to get shared access to the resources that are being stood up because they're big investments. This is where it starts to become tricky. And our software exists to try to make that transition from, oh, great, I ran on my single, laptop or my Spark box sitting under my desk. Now I want to go run that in Crusoe Cloud or wherever, pick your provider. So what we've done, we are not a cloud reseller. We're not a broker. We're not charging for cycles. We make it easy to make our software plug into these NeoCloud or GPU as a service providers with essentially a few clicks of a button. And I even got a story yesterday. We went to a GPU aggregator called Valdi, owned by Storj now. I spun up a A100 node, paying like $1 an hour or not even. Took the IP address that comes out of that, plugged it into our platform, and I was in about 5 minutes running Jupyter notebooks, VS Code, OLlama deployments, automated on that type of system very easily. It connected in just like that. So, and that system is immensely scalable. I can now go up and spin up another 16, and it's just putting coins in the slot to be able to scale. So we're kind of working with these GPU providers more from that reference architecture perspective. We go in and we actually just announced a partner ecosystem a few days ago. I put it on our website where with all these vendors, we go and test that their infrastructure is supported by the various capabilities that our platform offers. Whether you're running in a single instance mode or a Kubernetes cluster or a batch scheduler, we go in and test these things and validate them so that when a user comes along with their own account at Voltage Park or Crusoe or name your cloud, we kind of validate that they work. So that's pretty much how we're working. And again, it's about usability. A lot of these GPU as a service providers, they're giving people single bare metal or VM machines with maybe multiple GPUs per node, and then you can scale up horizontally. But a group needs to come in and then actually, lay something down to run a workload over that. we kind of have that ready to go out of the box. You can come in, click a button, run any of these higher level services very simply.
Let's talk about cost and efficiency, because the moment we start looking at GPU kind of utilization, and especially in the cloud world, cost does become a factor. Let's just have a discussion on cost and efficiency. How do GPU utilization and cost control factor into your customers' decision to adopt your platform?
Yeah, I'm seeing from my perspective and all the different things that our software does, the thing that really has been evolving as the standout capability that translates to like the value prop or ROI for our customers and future customers is about uniform usability tracking, which then translates to chargeback or cost control and chargeback capabilities. So what we're seeing is that when you put in these shared infrastructure systems within an organization, whatever the shape of them, it's a new 30 million NVIDIA system you just bought, in your hedge fund, and you're now you want to make that thing available to your group of quants, for example. How are you going to track which parts of the organization are using what, so that you can charge back accordingly, or even just give them visibility in what they're using, and then a lot of time spending. And it becomes almost like a behavioral aspect where, as me as an end user can start to see what I'm spending, I can start to contain the workload in the right size of infrastructure for the thing that I'm running on, and not waste a bunch of stuff. Because a lot of times we see, like, without a system like what we're describing, like some chargeback or usage, tight usage tracking capabilities across system types, a infrastructure team says, here you go, here's your new, GPU node that you just requested. It has eight cards on it. When in fact, the end user maybe only needs a fraction of one, because they're running lightweight testing of their model before they want to scale it out. And they spend 8 months with a 8 or 16 node GPU box when they're really just using a fraction of one card. The amount of waste and basically idle resources that translates to, and then you multiply that out across an organization, is, I think, a big reason why, at least we're seeing, a lot of these types of systems yield low utilization rates, especially in their early deployment times, months to even years in some cases. So what we're, kind of this idea of cost efficiency, but really it translates to like system utilization, coming in, giving clear usage and cost tracking metrics to the end users so that they have visibility to what they spend, letting an organization actually keep track of what they're spending at a fine resolution across system types, not just Kubernetes, but like across everything, really translates, we're seeing, to higher utilization rates of these systems. And we're hearing that people that are buying these systems, and they're maybe renting on neoclouds today, they want to achieve high utilization rates day one. How do they do that? This is a system that helps make that possible. At least that's kind of the narrative that we've been saying, and I think we're actually seeing that come true in real life now. Yeah.
Since you cater to the global market, and in this changed geopolitical world that we're living in, a lot of things are changing. The whole trade war is going on, tariff war is going on. There are real wars going on in Middle East and Europe as well. Countries are becoming very, very data sovereign. They are also concerned with privacy. A lot of laws are being passed. How are you accommodating to this changing global? Because AI becomes a very, very. There are some laws in France and Europe. So how are you ensuring that when customers use your platform, irrespective of the region, it respects the regional laws?
Yeah, it's a great question. And I think, again, in this adoption curve that I keep referring to, it's early, and we're seeing that pick up a lot. This idea of sovereign AI, and basically the end users themselves that are running on these systems need to be running in a place where they're allowed to. And it actually is almost making the case for hybrid multi-cloud systems and then a control plane to help manage them. Even more important, because it starts to become expansive, where we're not talking about one or two clouds now. We're talking about potentially lots of them, even ones that are local, and a mix of lots of data centers in these different sovereign areas within a same network boundary of an organization, perhaps, or disconnected boundaries. So the approach that we're taking to that is, again, our two stakeholders. It's the infrastructure teams that we're supporting, and then the end users that they're supporting in their organization. We're adding capabilities into our platform that allow the infrastructure teams to set policies on where their end users can run. And they can say that, this group of users that may be sitting in the EU is only able to run on this set of, infrastructure that's connected into the network, or maybe disconnected on separate networks. And when that's exposed to the end users, they don't actually have any more visibility than that, is the idea. So, and in fact, the underlying infrastructure to where the compute tasks actually are running becomes even more transparent. It disappears from where the end users are able to run. They are focused on submitting compute tasks of whatever type they want. I want Olama running. I don't care where it is. I want it best performance at best cost. You move to a model where you're specifying rules like that. And a system such as ours helps actually make that possible within the sovereign or geopolitical environments of these organizations. So that's kind of the direction that we're moving to, which is, a lot of opportunities there. And again, early in the adoption curve from capability need, but it's definitely picking up.
Where do you see AI infrastructure management evolving over the next, let's say, 12 to 18 months? And what role do you see of Peller work playing in that space?
From an AI infrastructure perspective, I see it, again, this transition from more of the public or managed AI services into private AI is upon us, and it's going to be happening more beyond just the hyperscale organizations. Like every organization is going to be starting to figure out the time that that's going to happen when we have the workloads to support it, which means that the infrastructure teams need to now operate private AI infrastructure systems that have all the things we just described and challenges upon that. And then right after that, there's the transition into, pushing down the stack out to the edge. As we're distributing, we're going to put, an AI system in every single one of our stores. And now we have workloads that are running over there. I suspect that's on the roadmap for the next 12, 18 months. And we fit right into that because we make that transition process, whether you're running on managed services or public clouds, onto private, centralized data center AI systems or all the edge. It's a uniform experience for us between all of those things. That's our goal. So when an end user's in there working on these workloads, they're simply pointing to a different location, or in the near future, like I was describing, they don't even need to point to a location anymore. They have infrastructure policies set up that make those, the underlying infrastructure basically disappear. It goes away in their views. And it's like the organizations are managing these policies of where people can run. They're submitting their tasks, and it's getting taken care of with some objective. So that's kind of like in the next 12 years. It's interesting. People are asking what's going to happen with HPC in the next 5 years as well. We're responding to National Lab RFIs and things on now about where are we going to be in 5 years for HPC, which in that world, it's been talked about more. They want to operate these big batch scheduler supercomputing systems more like a cloud, actually, and have them all converge together in a single, have them kind of act as a single system. And regardless of what the flavor of cluster that end users want to actually access, again, it kind of gets a little more I'd say disappearing behind the policies, I guess. So yeah, that's my response there.
Matthew, thank you for joining me. It's quite clear by now that orchestration, not just compute, is going to be a core competitive advantage for enterprises scaling AI. And platforms like Pellerworks are showing what that future can look like. Thank you for joining me, and I look forward to working with you folks again in the future. Thank you.
Yep, thank you so much. Great being here.
And for those watching, stay tuned for more conversations with the leaders building the infrastructure behind enterprise AI. Thanks for watching. Don't forget to hit the subscribe button and don't forget to hit that notification bell. So every time we upload a new video, you are notified. Thank you so much.